Hi, this is Stuart from Cellusys, and I want to show you a product demonstration we've put together to address the global problem of phishing attempts over SMS, which some people call smishing. Why have we done this? I've worked in the mobile industry for about the last 18 years, and smishing has been around all that time, and really the industry has done nothing to address this. Only yesterday there was a new SMS phishing scam that was happening for HSBC, a bank here in the UK. And perhaps it's hardly surprising when surveys reveal that typically a very, very small proportion of people can accurately identify phishing attempts. So I wanted to think about what we could do that was different in order to address this problem. Partnered with our friends at MetaCert, who are global leaders in the world of phishing protection on the internet, and I wanted to see what we could do to bring something together to address the problem within the global mobile network operators. So we've put together a demo site here, which actually sends and receives messages with a phone over here on the right hand side that you can see using the Let's View app. And oh, I've got a message there already. Let's have a look and see what that says. Oh, there's been some unusual activity on my credit card account, and I've been sent a link to click to, but I don't actually know if that's correct or not. Maybe there's a better way of doing things. So let's have a look at this product demo and see what we put together. There's a website here that uses technology. It's integrated to MetaCert and uses Twilio actually to send text messages to the handset on the right. I've put in the MSISDN of the handset already, and I've put in an example message which says hello from apple.com. Now what we know about apple.com is that is a legitimate URL that belongs to Apple. I'm using demo A here, which you can see at the bottom, and what demo A does, it does a dip on the MetaCert database to verify URLs, and depending on what they are, it actually inserts emojis into the destination message. So if I send this message that says hello from apple.com to the handset, after a little bit of processing, you'll see it pops up on the right hand side here and it's been received on the handset. If we dive into messages, we can see the same message, hello from apple.com. But having done a lookup on apple.com on the MetaCert database, where they've categorized a couple of billion known safe URLs, you can see we've inserted a green tick emoji to show that that URL is safe. So what would happen if we tried a URL that we knew was dangerous? If I put in, PayPal.com, I've left off the dot after the www, and actually this version of PayPal is actually a phishing site. It looks like it could be PayPal, and anybody who clicks on it without examining it closely might actually think that's legitimately PayPal. If I send that now to the handset, after we do a lookup in the MetaCert database, you'll see that we actually have sent a no entry sign, so an emoji has indicated that we know this is not a safe URL. We've taken away the dangerous URL and replaced it with another URL. We've actually put it through a shortening service called Cutly. That's just to save the SMS character limit. And if I was to click on that link for whatever reason, I actually get taken to a site that shows the website address that we would have been using, paypal.com, shows it's a dangerous site, and actually encourages me to get out of there and go back to safety. One of the challenges with domain names is actually keeping up with the number that are being registered every year, and it's not possible for the MetaCert team or any team to accurately categorize every single website in the world. So if I was to make one up here, this is a website that nobody knows about, probably doesn't even exist, it's not categorized. So how would the demonstration handle that? If I then send that to the handset and wait for it to arrive, you'll see that we don't actually know if this is a safe URL or not. So what we've done is we've appended it with a little warning triangle. The warning triangle is there to indicate to the user they should exercise caution before accessing that website. So that's how our demo A works. Let's have a look at another implementation, or a different way of doing this demonstration, and just to show that we've not hard-coded any URLs in, I'm going to use a different URL here. Samsung.com, obviously another legitimate URL. I'm going to use demo B and see how that's different. Just to make it nice and clear, I'm going to go into my messages and clear out all the old messages that I've received from the Cellusys ID. So let's send demo B a message from Samsung.com. A different user experience here. We've received a message from Samsung.com. We know it's safe. Because this URL is safe, there's no need to tell the user anything, frankly. We might as well just pass on the message exactly as it is. Hello from Samsung.com. The user doesn't know he's being protected, but there's full protection running in the background. Let's send another message, this time making up a URL just like we did before. We'll use the .de domain name this time. Send that message and see how this demonstration handles a different sort of message. This is how the unknown message is received. So again, we passed on the message exactly as it was, and we followed it up immediately with a second text message to say this website address may or may not be safe. We're not entirely sure. We haven't categorized it, so we're just urging the customer uses their discretion or uses some caution before they open the message. I'm going to send one more message. Again, I'm going to use my favorite not PayPal address to demonstrate how demo B looks after what we know to be malicious addresses. And here it comes, coming through in real time. We've actually, again, we've substituted the message. You can see we've taken out the URL, the fake PayPal URL, and also sent a warning to the customer just to let them know that that message is not the URL they've received. They've received a message with a URL that wasn't actually safe. And again, when I click on that link that we've created for them, you can see that we've put protection in place to stop them accessing a dangerous website. So again, I'm just going to go and remove all those messages so that I can show you what demo C looks like. I don't want to be accused of being in any way biased towards any particular type of handset, so let's pick another handset vendor. Let's pick OnePlus, and we'll use demo C to send a legitimate URL using a different methodology. Here we go. This is demo C, and in demo C you can see when we identify that the URL is safe, we actually sent a confirmation message along with the URL just to give the user that additional comfort factor that they know that URL is safe. Demo C, who knows what this website is? Where should we put it? Let's put it into Spain and send that, and we'll see how demo C handles this. Again, we've passed it through exactly as it was configured, and again put the warning on in the same ways we did with demo B actually, and then finally, just to follow up, my favourite not PayPal.com address, we'll send that through from demo C to the handset. And as you can see, yet again, we sent a warning message and replaced the URL to keep the customer safe. Thanks for watching the demonstration. We'd love to hear your feedback on what you think of what we put together, where you think it could be improved, and what we can do to work together to address this global issue of phishing attempts over SMS. You can reach us using the contact details shown on this slide, and we'd love to hear from you.